Good morning, dear students. Today we need to continue with our module of Fundamental Physics, Part 1 of Classical and Fluid Mechanics. As time flies, we need to talk about Unit 3, which is Dynamics of a Particle, especially called Dynamics of Translational Motion. Here we'll learn about Newton's laws of motion and their applications. Starting with the basic, here comes the three questions. The first one, what makes an object at rest begin to move? Second, what causes a body to accelerate or decelerate? This is when a body is moving with constant velocity. What makes it to accelerate or to decelerate in order to stop? What is involved when an object moves in a circle? Then here the answer comes that a force is needed. It means that a force is a push or a pull on an object is needed to change the state of rest or the state of motion of a body. Here to say the state of rest means when a body is not moving at all, the body is said to be at rest. Then to start moving, there is a need of a force. Or to say the state of uniform motion means when a body is moving with constant velocity. Once the velocity changes, the body gets an acceleration. To get an acceleration, the body must have a force acting on it. Then dynamics is the study of physics dealing with the forces, means the causes of motion and why objects move as they do. Here comes the definition of a force, where the force is a push or a pull on an object, which means an interaction between two bodies or interaction between a body and its surrounding. Then we continue with Newton's laws of motion because these laws govern the motion of bodies. Newton has three laws. The first law states that every body continues in its state of rest or uniform speed in a straight line unless acted on by a non-zero net force. This means that if the sum of forces acting on a body is equal to 0, then the acceleration of the moving body is equal to 0. If the acceleration is equal to 0, then the body has a constant velocity or the body is not moving at all. We continue with Newton's second law of motion, which is called the fundamental principle of dynamics. This has a statement that the acceleration of an object is directly proportional to the net force acting on it and is inversely proportional to its mass. This means that once the velocity of a moving body changes with time, the body is said to be accelerated. Then this acceleration is equal to the sum of forces acting on a body divided by the mass of the body. Or we can state this law as the net force, means the sum of forces acting on a moving body is equal to the product of mass and the second law of Newton may be stated for a body moving in atmosphere near the surface of Earth. It is especially for a projectile. We know that the projectile is a body which moves in atmosphere near the surface of Earth. And then the force acting on a projectile body is called the weight of the body, and the weight of the body is equal to the mass of the body times the universal acceleration due to gravity, then W equals mg. This weight of the body is actually called the force of gravity Fg. The third Newton's law is called the law of action and reaction. This law states that for every action force in the universe, there is always an equal and opposite reaction force. This means that when two isolated bodies A and B exert forces on each other, this means that if body A exerts a force on body B, which is called action force, then body B will exert an equal and opposite force on body A called the reaction force. This means that the force FAB means the force that body A exerts on body B. It has the same magnitude as the force BA, means the force that B exerts on body A. And it is clear that the two forces are in opposite direction. Then the force that A exerts on B plus the force that B exerts on A is equal to 0. In first law, second law, and the third law of Newton, we talked about forces, and the force is taken as the cause of motion. And then here we need to know what are the types of mechanical forces that act on a body. Here we consider a block which is sliding, a body which is sliding on an horizontal table. Then if this body is placed on this horizontal surface, then this body or this block exerts a downward force on the surface. This force is the weight or the force of gravity of this block. And there is a contact force. The contact force we have here is the force that the surface exerts on the block. It is said that this force is called the normal force N or Fn. Then the normal force is a force that the surface exerts on the block in a direction perpendicular to the surface. It's the reason why here the surface is horizontal, so the normal force will be along the vertical axis. There is another contact force which is called the friction force. Friction force is a force between the bottom of the block, means the bottom of the moving body, and the top of the surface. By considering an example of a car moving on a paved road, the friction force is a force between the bottom of car tires and the top of the road. Then this is a force of resistance. We may take an example. Once you are driving a car on paved road, the car moves quickly without any stress. But if you are driving on an paved road, let us take an example of the road from Karisimbi to the gate of Ines. The car feels resistance. Then this resistance is called the force of friction. Here comes another force, a force oriented in a direction of motion, which is called the motional force. Here, actually, this motional force, once the body is connected to a string, this motional force is called the tension force. The tension force means a force on a string. And here comes the definitions. The motional force is a force which is exerted in a direction of motion, while the weight or the force of gravity, of gravitational force Fg, is the force that the body exerts vertically downward on the surface, or a vertically downward force, means the weight of the body. The normal force N or Fn, as I told you, is the force that the surface exerts on body in a direction perpendicular to the plane. And The normal force is a contact force arises from repulsion between the atoms of the object and the atoms of the plane. And this repulsion prevents the object from penetrating the plane. We may take an example. Once you are sitting on a desk, then you cannot penetrate into the desk because of this normal force. There is the last force is what we call the force of friction. As I said, this is a resistance force to the motion of the moving body. Here we may distinguish between the force of static friction and the force of kinetic friction. Once this resistance to the motion is as much as possible, then this force of friction opposes the motional force. In this case, the body doesn't move at all, and then the force of friction is called the force of static friction, which is equal to mu s n. Then once the body still feels a resistance and the body continues to move, but still the resistance is there, that force of friction is called the force of kinetic friction. And the force of kinetic friction is equal to the coefficient of kinetic friction mu k times the normal force. They will use this formula and definition while solving problems.